Hey, fifth graders. We just wanted to introduce fractions to you with this money model. A lot of us are comfortable with money. We understand how money works and are familiar with things like quarters, dimes, and nickels. And so we're going to use money to kind of introduce the idea of fractions. Maybe it's a refresher for you, and maybe you're just learning it now. But either way, the money model really helps us kind of put things into perspective for fractions. So when we're talking about fractions, fractions are a part of a whole. And so when we're looking at things like quarters and 50-cent pieces, they help us kind of see the amount of money we have out of a whole dollar. And the reason we like to use money is a whole dollar is 100 cents, and out of 100 is a pretty simple fraction to start using. So we're going to take a look at a couple different pieces of money and looking at their related fractions. So when we're looking at 50-cent pieces, a lot of people will say 50 cents as half a dollar. Okay, and now when you're looking at it as money, 0.50 is out of 100 cents. It goes to the 10th place and then the 100th place. So if you were looking at this, it would be 50 out of 100, or an equivalent fraction is saying 1/2. Next, we're going to look at quarters. So quarters, when you hear quarters, you know that a quarter is worth 25 cents. So a quarter is worth 1 out of 4 of an entire dollar, or a quarter. Now again, if we're looking at this as a fraction of a whole dollar, it would be 10th place, 100th place. So it would be 25 hundredths, or 25 over 100. Okay, now we're going to look at dimes. And these pictures are nice because they show you how many dimes it would actually take to cover up. If you look at this, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces it covers up out of the whole dollar. So that would represent 10 cents. And how many dimes it would take to cover a whole dollar? It would take 10 dimes. Now a dime is worth 10 cents, or 1/10 of a whole dollar. And another way to say that in the money sense would be 10 out of 100. And now we have nickels. Nickels are worth half as much as a dime, so it would take twice as many nickels to cover a whole dollar. And as you can see, it's going to take 20 nickels to cover this whole dollar. Now, if we're looking at it as out of a whole dollar, out of 100 cents, it would be 5 out of 100. And the last one we're going to look at here are pennies. And a penny takes up one little square out of all of these. And if you were to count all of these up, there's 100 little squares in here. So 1 penny takes up one little square. It would take 100 pennies to cover this up. So a penny is worth 1/100th of a dollar. And it would also look like 1 over 100 in terms of cents. So how does that help us solve money fraction problems with money? Okay, we don't have pieces for this for a fifth of a dollar. We don't have a piece for a 1/25th of a dollar or 1/50th, but you could still break a dollar into these equal parts, and that's something we'll take a look at as we get into this unit. But how does this help us solve problems knowing what the money and the coins are equal to? If you had a problem that looks like this, 1/2 plus 1/4, okay? Now, when we're adding fractions, you don't just add the bottom numbers together. So what you have to do is you have to find a common number that these both share, and you have to find equivalent fractions, we call them. So fractions that mean the same amount, but they actually look different. And so the way that you might do this is you might think of it as money. So you might think of this as a 50-cent piece of a dollar. And we know that that counts for 50 cents, or 50 over 100, we learned. And then you have a quarter here, so you could cover that with a quarter. And we know that that stands for 25 cents, or 25 out of 100. And when you look at it this way, you see that these both have the same bottom number now. This is called a denominator, and they have the same denominator now. So when you look at it this way, they've got 50 over 100 and 25 over 100. And in fractions, when the denominators are the same, the denominator stays the same, and you add the top numbers, or we call those numerators. So in this case, you'd have 75 over 100. And that can be reduced. We'll get to that later on in the unit. But for right now, we just added these two fractions that have different denominators. Now, how would you go about solving this next problem?